Good day, class. You are once again welcome to our chemistry online class for this week. My name is Ojorifos Oluwakayode. Still your chemistry teacher for the online class. Today we'll be talking on mass-volume relationship. Mass-volume relationship. In our class, we deals with solubility and we conclude on that topic, solubility. And we look at how to calculate the solubility of substance. But today we'll be looking at mass-volume relationship. For this particular class, the objective are as follows. At the end of the day, I expect you to be able to describe the relationship between a mass and the volume of a substance. 2. Describe the relationship between the mole and the reacting mass of a substance. Lastly, you should be able to establish a relationship between mole and molar or volume of a gas. Relation between mole and volume of a gas. Now, understanding this topic properly, let's quickly look at what is called stoichiometric of a reaction. The stoichiometric of a reaction simply expresses the mole ratio in which reactants combine to form a substance. Thus, the reactant and product in a chemical reaction may be ion, atoms, and or a molecules. However, the molar quantities involved in the reactions are not affected by the kind of particles present. So, stoichiometric helps us to understand the ratio in which a reactant is combining to give a particular ratio of products which are formed. That is, if A and B is to combine to give C and D, what is the ratio of A and B combining to form the ratio of C and D? So stoichiometric helps us to understand better what is the number of A reacting with B to give B and C. And this is best understood from the chemical equation of the reaction. Let's talk about mole ratio and mass relationship. What is a mole? Recall, we said that a mole can be defined as the amount containing as many elementary entities as the number of atoms present in exactly 12 grams of carbon-12 isotope. Thus, the numeric coefficient of a balanced equation represents the numbers of moles of reactants and product. So if you are looking at A reacting with B to give C and D, and we are having 2 of A reacting with 1 of B to give 3 of C and 1 of D. That means that the mole ratio there is the numbers of A reacting with, that is the coefficient of A reacting with that of B to give C and D. Mathematically, numbers of moles are expressed as mass of a substance all over the molar mass of a substance. I hope you have not forgotten this. Mass of a substance all over molar mass of a substance. Example, if you are to calculate the mass of calcium chloride that can be obtained from 25 grams of limestone, the mass of calcium chloride that can be obtained for 25 grams of limestone in the presence of excess hydrogen chloride. Now, what does that mean? Now, let's look at the equation of the reaction. We are having calcium triisocarbonate reacting with hydrochloric acid. When calcium triisocarbonate reacts with hydrochloric acid, 3 products are formed: calcium chloride, water, and carbon dioxide. Now, if you look at the stoichiometric of the reaction, how much of calcium triisocarbonate 4 is reacting with hydrochloric acid, you will discover that we are having 1 mole of calcium triisocarbonate 4 reacting with 2 mole of hydrochloric acid to give 1 mole of calcium chloride, 1 mole of water, and 1 mole of carbon dioxide. Now, the first process or the first stage in the calculation, convert the 25 grams of the calcium triisocarbonate 4 to mole. And what is mole? Mole is mass over molar mass. That means that by the time you take 25 grams of calcium carbonate 4 all over the molar mass of calcium triazocarbonate 4, which is 100. That gives us 0.25 moles of calcium triazocarbonate 4. Therefore, that means that 0.25 from the stoichiometric of the reaction, 1 mole of calcium triazocarbonate 4 produce 1 mole of calcium chloride. Take notes, 1 mole of calcium triazocarbonate 4. Now let's do mole comparison. 1 mole of calcium triazocarbonate 4 produce 1 mole of calcium chloride. Therefore, 0.25 mole of calcium triazocarbonate 4 will give 0.25 mole of calcium chloride. Example 2. Determine the mass of carbon 4 oxide produced on burning 104 grams of ethane. Now, what do you mean by burning? That this ethane reacted with oxygen. From the equation of the reaction, you see that clearly. When ethane reacts with oxygen, we have two products formed, carbon 4 oxide and steam, which is water vapor. Now, if you look at that reaction very well, you find out that 2 mole of ethane reacts with 5 mole of oxygen. 2 mole of ethane from the stoichiometric, 2 mole of ethane is reacting with 5 mole of oxygen to give 4 mole of carbon 4 oxide and 2 mole of water vapor. Now, the first stage here also, like we did in the first example, convert the mass of ethane to mole. What is mole? Mass, reacting mass all over molar mass. Therefore, we are having the molar mass of ethane as 26 grams per mole. So when we take this, the 104 mass of ethane to mole, that will give us 104 all over 26, which is 4 mole. 4 mole. Now, going back to the equation of the reaction. From the equation of the reaction, we can deduce that 2 mole of ethane produces 4 mole of carbon 4 oxide. Therefore, 4 mole of ethane will produce 4 times 4 divided by 2 moles of carbon 4 oxide, which is 8 moles of carbon 4 oxide. Since 2 moles produces 4 mole, so therefore 4 mole will produce 8 mole of ethane. Now, the second stage is now convert this 8 mole of carbon 4 oxide, which is produced, to mass. Now, recall, mole is mass over molar mass. Now, when you input the information, 8 moles is equals to the mass which we are looking for all over the molar mass of carbon 4 oxide, which is 44. And you make the reacting mass of carbon 4 oxide the subject of the formula. That will give us 8 times 44, which is 352 grams of carbon 4 oxide. That implies that 352 grams of carbon 4 oxide is produced by 104 grams of ethane. I hope you understand that calculation. Relationship between mass and volume. Recall, Avogadro's law states that equal volume of all gases under the same condition of temperature and pressure contain the same number of molecules. Under the same condition of temperature and pressure contain the same number of molecules. That implies that 1 mole of any gas at XTP occupies a volume, a standard volume of 22.4 dm3, which is same as 22,400 cm3. 22.4 dm3, which is equivalent to 22,400 cm3. Therefore, from this molar volume, we can calculate the volumes, moles, and numbers of molecules of gaseous reactants and products from a balanced chemical equation. Example: find the volume of oxygen produced by 0.4 mole of potassium triazocarbonate 4. Please correct that. Potassium triazocarbonate 4 at HTP. In the equation of reaction, we are having 2 mole of calcium triazocarbonate, 2 mole of potassium triazochloride 5. Potassium triazochlorate 5. Potassium triazochlorate 5 reacting to form or decomposing to give 2 mole of potassium chloride and 3 mole of oxygen. I repeat again, 2 mole of potassium triisochlorate 5 decomposing to give 2 moles of potassium chloride and 3 mole of oxygen. Now, from the stoichiometric, we are having 2 mole of potassium triisochlorate 5 to 2 moles of potassium chloride to 3 moles of oxygen. Now, from the equation of the reaction, we can deduce that 2 mole of potassium triisochlorate 5 will give 3 mole of oxygen. Therefore, 0.4 moles of potassium triisochlorate 5 will give 0.6 mole of oxygen. So therefore, take this 0.6 mole of oxygen to volume. Recall, at STP, 1 mole occupy a volume of 22.4 dm3. Therefore, 0.6 mole of oxygen will occupy what volume? That is 0.6 times 22.4 dm3, which is 13.44 dm3. That means that the volume of oxygen produced by 0.4 mole of potassium triisochlorate 5, like I read, that is potassium triisochlorate 5, is 13.44 dm3. Number 2, find the mass of sodium triisocarbonate 4 needed to give 5.6 dm3 of carbon 4 oxide at STP. Now, from the equation of that reaction, you are having 2 mole of sodium triisocarbonate 4 reacting with 2 moles, you're having 1 mole of sodium triisocarbonate 4 reacting with 2 moles of hydrochloric acid to give 2 moles of sodium chloride, 1 mole of carbon 4 oxide, and 1 mole of water. Now, at STP, we know that 1 mole of carbon 4 oxide occupies a volume of 22.4 dm3. Therefore, that implies that 22.4 dm3 of carbon 4 oxide gives 1 mole of carbon 4 oxide. Thus, 5.6 dm3 of carbon 4 oxide will give how many moles? Now, from calculation, from what I did in the example, you discover that gives us 0.25 moles. 0.25 moles of carbon 4 oxide. If 22.4 dm3 is equivalent to 1 mole of carbon 4 oxide, so therefore 5.6 dm3 is equivalent to what? 0.25 moles of carbon 4 oxide. Now, going back to the equation of reaction, you can now say that 1 mole of carbon 4 oxide was produced by 1 mole of sodium triisocarbonate 4. Thus, 0.25 moles of carbon 4 oxide will be produced by how many mole of sodium triisocarbonate 4? That is equals to also 0.25, since this is 1 mole to 1 mole. So it's also equivalent to 0.25 mole to 0.25 mole of sodium triisocarbonate 4. Now, converting the 0.25 mole of sodium triisocarbonate 4 to mass, we know that numbers of mole is equals to what? Mass over molar mass. Molar mass of sodium triisocarbonate 4 is 106. Now, in putting that in the formula, moles is equals to mass over molar mass. That gives us the mass of sodium triisocarbonate 4 to be 0.25 times 106 gram, which is 26.5 gram. 26.5 gram, which means mass of sodium triisocarbonate 4 needed to give 5 dm3 of carbon 4 oxide at STP is 26.5 gram. With this, we have come to the end of the class. I have not been seeing feedback or getting feedback from you students. You have not been submitting my assignments. You just attend class, not taking your assignment serious. Please always do that. Submit to my WhatsApp number 080. For now, this is the only medium through which we can communicate. 08034187864. Number 1, define a mole. Number 2, state Avogadro's law of combining volume. Number 3, calculate the number of moles of sodium chloride produced by reacting 168 gram of sodium triisocarbonate 4 with excess hydrochloric acid. Number 2, find the mass of sodium triisocarbonate 4 needed to give 44.8 dm³ of carbon dioxide at STP. Till we meet again in the next class, stay safe.